You are here. I'm so glad you're here, and we're all here together. My name is Hippie Hacker, and I care deeply about all of us and being able to work together well. Beyond us just being here, a good question might be, a moment to navigate the slides. Why are we here? I think we're here in order to be able to share all of the powerful things we can do with everyone all over the world. We might use some technical parlance and say we want production workloads worldwide. But generally, what we're saying is we want that to be available for everybody. That's what generally available means. In order for that to happen, we need to have some minimum requirements defining what it is that is Kubernetes. That's going to require us to have sustainable ecosystems for development and for deployment that are not specific to a particular vendor, but something that's available to all of us to have in our own nations and our own communities. It's important that we realize this is for all nations and all neighborhoods, not just some of them. When we have these fancy containers for shipping all of our ideas around, we need to remember they need to arrive at ports of call in other countries, which may have different customs and different protocols that need to be adapted. But the orchestration of how we bring together all of our ideas is why we need some type of certification program. This Certified Kubernetes Provider certification program allows us to, with confidence, know that our workloads are going to run everywhere where you see this logo. In order to understand the surface area, we have some tooling that we've put together. API Snoop.cncf.io is a tool that we use to understand the surface area of Kubernetes, the API surface area. All of your applications use some portion of it, the green being nice and stable, the blue, the beta, and the alpha. Let's not do that everywhere just yet. To draw a parallel to that, I'd like to go through some of the cloud coverage and understanding the surface area of our planet. In 1960, we sent up a satellite called Tyros-1. It was the first TV broadcast from space. It's our first view and glimpse into our planet and where the clouds were. In 1972, we got the world's most famous selfie. That selfie is called Blue Marble, and it was taken by the crew of the Apollo 17. If we fast forward a bit into the 90s, we had a probe that we sent out to explore our solar system, and it was able to reach 30 degrees above the ecliptic and look back at us. It was a pale blue dot. If you look in that third red band, you'll notice there's a pixel that 1/3 of it is slightly blue. That pale blue dot is Earth, taken from Voyager 1. If we go along a little further, we'll note in 2001, there were a lot more satellites, and we were able to take images from all over the planet and combine those together to get a full understanding of our entire surface area of Earth. By 2002, we started to be able to take an entire snapshot of the whole Earth and be able to remove the clouds to see what land is underneath, remove the ice to see where we could actually build stuff, and of course, most importantly, focusing on the people. This is why we're here, is for all the people everywhere. To draw a parallel in our surface area of Kubernetes, back in 1.10, we had some software written by a member of our community to look at the log files when we run our ii test suite. Ken Omichi noticed that we weren't testing more than about, I think, 11% of the possible APIs that Kubernetes can provide. And that was a concern. In 1.11, we started looking at audit logs as far as the audit events themselves, manually generated by the API server. We took and set up a static website, the first API Snoop.cncf.io site, and Rowan Fletcher was another member of our community that helped to set that up for us. In 1.12, we got our first glimpse of actual test coverage. What happened was the API server, anytime your applications talked to it, was now sending who was talking to it via the user agent. And we updated our EDE framework to allow recording which test we were running, so we could tell if it was a normal test, a conformance test, and that was thanks to Zhonghu Zhu. And 1.13, we got our first glimpse of coverage over time. API Snoop CNCF.ci was set up to process all of the audit logs from our CI jobs. That was some work done by Devin Carpenter. In 1.14, we were finally able to start asking and answering questions by dynamically querying all of the information we had. And we'll go through some of that in a demo here shortly. A lot of that work was thanks to Zach Mandeville. 1.15 was a really neat release. What happened then was a policy was put in place requiring that any features that make it to general availability in Kubernetes are required to have conformance tests. We had promotions from beta into general available where we were able to post links to API Snoop saying, you're almost there. These are the last few endpoints we need tests for. And Aaron Krickenberger, SpiffX, thank you for making us be honest about testing and putting that policy in place. He was the release lead for 1.15. 1.16, we're defining new metrics of API service. So whether it's all of some 1,400 endpoints or all of the different values of the Kubernetes API that you can use. Jordan Liggett added some support for recording that. Thank you, Jordan. 1.17, we need to test the infrastructure that we all depend on, and this is where you come in. This is the information on the Kate's Conformance Certification Program by the CNCF, as well as the API Snoop CNCF.io site to show you the current amount of testing coverage, conformance coverage, and lack of tests. I'll do a demo now that may help us to all understand how to write tests. Give me a moment because I'll have to figure out how to navigate the screen. Is that one? Probably that one. No. This one. There we go. Give me a moment over here. So, because I'm going to be typing a lot, I'll move the mic over here. This is the presentation we just did. We're going to go over to a walkthrough. This walkthrough is going to set up a cluster and help us identify some unused features and look at some documentation, as well as writing tests. The writing of the test could be something where you run your applications while this is deployed, so you can get an idea of what your application actually uses versus what you think it does. So as we go through this setup, I will, excuse me while new, 1 second. We lost our red eye, that's okay. So I'm going to create a cluster using kind. that's going to be running in another window. You'll notice the configuration for kind includes setting up some alpha features for API server, including audit registration. This allows us to deploy inside of your cluster a endpoint that receives all of the information for applications talking to the Kubernetes server, the API server. The cluster is now up, so we'll mark that as done. Now we're going to make sure the cluster is up that we can communicate to it. And welcome to demo. Give me one moment to see if I can pull up our other window over here. Can't quite read that. We won't be able to use that eye. So we'll go back and recreate our cluster real quick. Kind is a really great tool for doing local development. It allows you to deploy Kubernetes anywhere that you have Docker. And we use it often for writing and developing tests. It's also a major part of the CI, or all of the testing that we do within the Kubernetes community. It'd be great to take a look at that. Here's our cluster that's having some trouble coming up today. We'll go ahead and walk through the steps. When we deploy API Snoop, it's pretty straightforward, where you can just do kubectl apply, and it will apply this template where we have 3 services, a database that's been customized to let us query information about Kubernetes, and your deployment. Let me try it one more time. So I think since the demo seems to be not agreeing with me today, we may go back and I'll show you some stuff on the API Snoop web interface. Not the web, there we go. I think I don't have internet. That's why this isn't working. Give me one moment. I think there's an Ethernet cord up here. I apologize. I set up everything next door and walked through it, and it was wonderful. And then I realized I was in the wrong room. One more time. We'll try this real quick to see if we get some internet. Does that appear to be loading? There we go. So this is API Snoop and its ability to measure surface area. If we turn off our areas there, you can see the endpoints that are currently untested. And if we focus on the green area, we can see these are if you use any of these, currently we're not guaranteeing that they're available everywhere, but we look forward to increasing that. These are areas that are tested, but they're not part of the conformance suite. And then here are all of the conformant endpoints that are filled in. Ideally, you want to fill in all the blanks. So we want to make sure that your applications depend only on the things that are guaranteed to run everywhere. Give me one more time to try to run through and reconnect the demo now that we have internet back up and running. And Here's our cluster one more time. If you have your own clusters, being able to understand what's happening within your cluster is a really valuable, gives you valuable insight into the whether you're using alpha APIs and maybe you don't know it, whether you're using beta endpoints. So we've now, it seems to have come back up real quick. Let's see if. Sorry about that. So I'm going to reset some ideas real quick on what we're going to do. So the ET test suite itself is available at github.com Kubernetes. And within there is the test folder. And this is where all of the testing starts. When we submit tests to this repo, all of our special interest groups all are aware that they need to be writing tests to fill this in. And these tests get defined and flow into some software called Test Grid. I can't see the screen real well. Kate's Test Grid. All right, I can't see it very well from here. The test grid is where all of our CI jobs run and generate the artifacts for us to understand how our tests are doing. When we write our tests, they allow us to see across all of our different providers how well they're doing. The certification program that the CNCF set up has a really straightforward set of criteria to follow. Get the mouse over there. It's at github.com CNCF. Kate's. There we go, and the instructions for submitting it are here. When you run the test and submit them, they go through a PR process where they get reviewed by members of the CNCF to assure that that the cloud providers submitted to this program actually ran all of the conformance tests, so that you can be sure that your applications are sufficiently will be able to run everywhere. Let me see if I can pull. I can't seem to type over here, so I'm going to pull up the browser and move it to where I can see. I'll be able to type a bit. Apologies for the technical glitch. Well, you're here, and so am I. I encourage you to take a look at API Snoop and running it in your clusters. Again, you can see that at github.com/CNCF API Snoop or apisnoop.cncf.io. Thanks for your time.